Section 2.7, we will deal with it's actually not an SI unit, but we're going to be dealing with volume. So we're going to be doing lots of volume measurements in our labs because a lot of the chemistry we will be doing deals with solutions or volume, where we'll be doing a lab about density shortly. But volume actually is not an SI unit, but as I said earlier, it can be derived from length, okay? So the definition of volume is how much space matter takes up. So if you guys remember, we previously talked about mass, and that's how much of something there is. So now we're talking about how much space matter takes up. All right, so there are two different units we'll be using for volume. That is either meters cubed, that will be for solids, or we'll be using the liter, and that's for liquids. So we'll be dealing with those two things with actually, and gases. Gases are also measured in liters. So to find the volume, this hopefully is review. You might be doing this in geometry too. But to find the volume of a solid, right, we just take the length times the width times the height. And as long as each of these are in meters, that will give us our units in meters cubed, if like we were determining the volume of a cube. Now, for a liquid, it's going to be different. Like we're going to be using lots of different things to determine the volume of our liquids, but we mostly will be using graduated cylinders. So the volume is measured with a graduated cylinder, and the units will be most of the time in milliliters. All right. So if you guys remember, there's 1,000 milliliters in 1 liter. So a liter is a pretty big amount. Like a liter is a water bottle, pretty much a big water bottle. And we're going to be using smaller amounts when we do our measurements. Now with graduated cylinders, we do have a scale. So we are going to have to use what we have talked about before with making length measurements, and we have to use our uncertainty. So measuring volume is we're going to have to be using both our uncertainty, and we're going to have to make our correct measurements based on how many marks we have. All right. Oops, sorry, I did that in the wrong spot. Okay, so parallax. So measuring volume, parallax is the line of sight, okay? So we need to make sure when oops, that's messy. When we do our volume measurements that we're looking directly at it. So when we actually measure something in a graduated cylinder, you want to like crouch down until you can see the fluid right at the same level. If we were going to look, like say that this is, here we are, here's our little eye, we're looking at something. If you look from the top, you can actually underestimate the amount of volume we have because of the angle. Same way with if we were here, let's say this is somebody's little eye here, looking from the bottom, we would overestimate it. So you want to make sure that when you measure, you're looking right parallel with the line of the fluid. Now the meniscus is the curve of the liquid. So this right here, this little curve right here is the curve of the liquid. Now, not all liquids have a meniscus. It depends on the surface tension, but water does, and we're going to be using a lot of water. So we will commonly have a meniscus, and we always want to measure from the bottom of the meniscus. So you want to measure looking here at the very bottom. You don't want to measure on the sides where it's up higher. You want to look at the bottom of the meniscus. That's the convention. Oh yeah, there we go. There's the parallax. It's a difference in the measurement due to the line of sight. So we want to measure right at eye height. All right, so let's go ahead and practice this. So here we have some liquid, and then this is actually vinegar, in its cylinder. Now you can notice that right here it says 30, okay, and right here it says 40. So that is the scale we're going to be using. We have different sized graduated cylinders in the lab, and they will have different scales depending on how big they are. So we have 10 marks in between here. There's almost always 10. So that means that each mark right here, each little mark right here is 1 milliliter. All right, so what is our uncertainty, if you guys remember? So the uncertainty is half of our smallest mark. So our uncertainty for this is going to be 1 milliliter divided by 2, or 0.5 milliliters. That's going to be our uncertainty. The measurement here is going to be 31, 2, 3, 4, 5, 6. And you can see we're measuring from the bottom, right? The bottom of the meniscus. So that's right about 36, I would say. So we know it for sure that it's 36. And then once again, with the scale, we guess one more digit. So we're going to say it's 36 point, I'm going to say 0. I think it's right there at the 36 mark. So this would be the correct way to measure this cylinder. All right, let's go ahead and do a couple more examples. All right, so let's look at this one on the left. All right, so now we have different scales. So this is a smaller graduated cylinder. It just goes from 0 to 1 milliliter. So that means that our smallest division right here, there's 10 marks. So that's 1 milliliter. So our smallest division is going to be 0.1 milliliter. All right, that means our uncertainty is going to be half of that. So it'll be 0.05 milliliters. All right, now let's look and see. So if each one of these is 0.1, so it's going to be 0.1, and we're starting with 0. So it's 0.1, 0.2, 0.3, 0.4, 0.5. So our measurement is 0.5, we know for sure. Now we get to guess one more. And remember, we're measuring from the bottom of the meniscus. I'm going to guess it's like right in between. So I'm going to say it's 0.55 milliliters plus or minus our 0.05. And that would be the correct way to read that one. All right, the second one down here in the middle, we have it's going from 0 to 10. So this is similar to the one we had in the previous slide, where each division here is 1 milliliter. All right, so our uncertainty is going to be half of 1 milliliter, or 1 milliliter divided by 2. So it's going to be 0.5 milliliters. Now, if we count and see where the bottom of our meniscus is, it's going to be 1, 2, 3, 4, 5, 6, 7. So that's 7 milliliters. Now we get to guess one more digit, so we got to put our decimal point. And once again, I'm going to say it's right in between. I almost always just guess I think it's right at the line, I'll put 0. If it's in between, I'll put 5. But you could actually, if you wanted to be more precise, you could put 7, you could put 3, but I'm going to put 5. So 7.5 milliliters plus or minus 0.5 milliliters as our uncertainty. All right, for the last one here, so this is a much bigger graduated cylinder from 0 to 100. So we once again have 10 marks. So that means that each of these little marks right here is going to be 10 milliliters, right? So our uncertainty is going to be bigger. It's going to be 10 divided by 2, or it's going to be 5 milliliters. That's going to be the uncertainty for this scale. Now our measurement, each one of these is 10, so it's going to be 10. That's going to be the first digit, right? And in between here, I'm going to guess, this time I'm going to guess 17. We're going to guess that's 17 milliliters plus or minus 0.5. All right. So notice that as our uncertainty gets bigger here, as we go down, we're guessing less digits. Okay. So those two are related. As our uncertainty goes up, we're guessing fewer digits in our measurement. All right, so we are going to practice this a lot in class, and this will also be one of the things that we will be doing in our lab practicum.